Hi everyone. Today we're going to go over question 6 of the June 2025 Regents exam for Earth and Space Science. So let's get started. So as always, you should underline or highlight any unknown words, word meanings, context clues, or important details on what a graph, diagram, or text is about, any relationships between things such as x decreases, y increases, or so on, and circle any verbs that are given to you called task verbs that is asking you to do something or to answer a question a certain way. So it says, base your answers to questions 6 through 10 on the information below and on your knowledge of Earth and space sciences. This means that questions 6 through 10 is a cluster, meaning that you're about to be given a lot of information such as text, diagrams, graphs, and all of that will be related to questions 6 through 10. So you need to be coming back and looking through multiple different modes of text to figure out the information. Some questions may also require the 2024 edition reference table of Earth and Space Sciences. So it says, modeling Earth systems to understand global climate. The geologic record shows a long history of climate fluctuations as a result of many different factors. I'm going to highlight geologic record because it gives me a context clue or important detail on what this text is about. And I'm also going to highlight climate fluctuations. This may be an unfamiliar word to some, and I'm going to highlight different factors because it's giving me a context clue on what the text is about to tell me. It's probably going to give me some factors on what impacts climate fluctuations and what scientists have found in the geologic record or the rock record. Climate scientists study models of Earth's motions, ocean currents, plate tectonic movement, and atmospheric composition to better understand energy flow into and out of Earth's systems. So I'm going to highlight models. They're studying models of Earth's motions, ocean currents, plate tectonic movement, and atmospheric composition. Highlighting all that, these seems to be related to the factors or giving us an understanding of the factors of climate fluctuations, and it's also giving us understanding of the energy flow in between the Earth system. So I'm highlighting that. Your highlights don't need to look the same as mine, as long as you're highlighting bits of information that gives you an idea of what the text is about. Obliquity, the tilt of Earth's axis relative to the sun, has a direct impact on Earth's climate. I'm highlighting obliquity because that seems to be an unfamiliar word, and I'm highlighting tilt of Earth's axis relative to the sun because that seems to be the definition of obliquity. I'm also highlighting direct impact because this is the second time I'm seeing impact or result of different factors. So it seems to be um, connected. So I'm highlighting that on Earth's climate. So before we talked about climate, so I'm highlighting Earth's climate. Okay. And finally, Earth's obliquity changes on a cycle that takes place over a period of 41,000 years. I'm going to highlight period of 41,000 years because it gives me an important detail on the timing. It seems to be a cycle, so it keeps happening over and over every 41,000 years. What keeps happening over and over? The Earth's obliquity changes. So it seems like the tilt of the Earth's axis, which is obliquity, changes in a cycle over and over again every 41,000 years. Now, the obliquity is currently decreasing. Important information, I'm going to highlight these, and will reach its minimum value of 22.1 degrees. I'm highlighting that important detail in approximately 9,800 years. Important detail. So now your highlights, even if it's different from mine, it should end up with something like when you're reading back at the text and you're only reading the highlighted parts, you get a full idea of what the text is about. So if I'm reading back, let's see. So the Earth's geological record is gives scientists an idea of climate fluctuations, the changes in climate, and which are a result of many different factors. Scientists study models of Earth's motions, ocean currents, plate tectonic movement, and atmospheric composition, and this gives them an idea on the energy flow between Earth systems. Obliquity is the tilt of the Earth's axis relative to the sun. It has a direct impact on the Earth's climate. Earth's obliquity changes in a cycle of a period of 41,000 years. Obliquity is currently decreasing with a minimum value of 22.1 degrees in approximately 9,800 years. So now I get an idea of what this text is about. Let's move on to this diagram here. It says maximum and minimum angles of obliquity. So this text or diagram must be showing me the minimum value of obliquity, the tilt of the Earth's axis, which is 22.1 degrees. That's right here. And the maximum value seems to be 24.5. And the current tilt of the Earth's axis seems to be 23.5 degrees, and compared to having no tilt, which is 0 degrees. And this is the energy from the sun coming into the Earth, or that the Earth is receiving. We were talking about energy flow here, so I'm highlighting that as well. Okay, so now it says the question 6, during winter, which statement best describes the amount of energy Earth's northern hemisphere will receive and the impact on global ice formation when the obliquity is 22.1 degrees compared to Earth's present obliquity? So I'm highlighting winter because it's an important detail. So they want us to talk about or look into winter. Which of these statements best describes? They want us to find the best description for the amount of energy that the northern hemisphere is receiving during winter, and it wants the impact on global ice formation. How will this impact the amount of ice forming globally when the obliquity is 22.1 degrees compared to Earth's present obliquity? So I'm highlighting all the words that are giving me important details. It wants a comparison to Earth's present tilt compared to the Earth's obliquity in its minimum tilt, which is 22.1 degrees. And we're comparing these tilts to see during wintertime what happens to the amount of energy coming to the northern hemisphere and also the impact on global ice formation. So let's quickly look at the reference table, just the first page. There's nothing here about obliquity, so I'm going to go back. You should always check the reference table very quickly if you can, to see if you can get extra information. So that now we need background knowledge. So let's go over it. So the Earth revolves around the sun in an orbit, and it also has a tilt. And from the text we know that this tilt can change in a cycle over a period of time. Sometimes it's at a minimum value, this tilt, which is 22.1 degrees, and sometimes it's at a maximum value, 24.5 degrees. But right now it's kind of in the middle, 23.5 degrees. With this tilt, as the Earth revolves around the sun, sometimes it's in this position where the northern hemisphere is tilted towards the sun, and this is what we call summer in the northern hemisphere because the northern hemisphere is receiving more direct energy from the sun. But when the Earth is in this position and the northern hemisphere is tilted away from the sun, we consider this winter in the northern hemisphere. The question 6 is asking for winter, so we're going to pay attention to here. And compared to the Earth's present obliquity, the tilt is right now, and we're going to compare to the minimum obliquity, which is 22.1. So if what would happen? Which statement best describes the amount of energy Earth's northern hemisphere will receive when the obliquity is 22.1 compared to present? So if the tilt is a little lower or smaller when the Earth is in this position, it would be no, the northern hemisphere would be a slightly closer to the sun, slightly more tilted towards the sun. So that means that it would receive a bit more energy. So that's why the correct answer is actually 3. Earth's northern hemisphere will receive more energy when the obliquity is 22.1 degrees compared to Earth's present obliquity during the winter, like this. If this was the summer and the tilt was this way a little lower, they would actually receive less energy because it would tilt away from the sun. So it all depends on not just the orbit, where the Earth's position is around the sun, and also its tilt. Now, it also is asking for the impact on global ice formation when the obliquity is 22.1 compared to current tilt. So if the obliquity, if the tilt is smaller, 22.1, the Earth's northern hemisphere is still facing a little closer to the sun, is tilted a little more towards the sun. That means there will be less ice in the polar regions because it's going to be warmer. If the Earth is tilted more towards the sun, it's going to receive more energy and there will be less ice in the polar regions. So that's why the correct answer is question number 3. So in the next video, we're going to talk about question 7 of the Regents exam. Thank you. Bye.